Right. Intermolecular force. Intermolecular force. Between. The word molecular is from what? Molecule. Now, here, renale intermolecular force. Intermolecular force is defined as what? The force that does what? That exists where? Between molecules. So now, we have got different forces that exist between molecules. Now, the forces that exist between molecules, they will be different. Why? Because molecules, they are what? Different. So there is a force that exists between the two. Kara relationship ya bona kumana lo re lwa lewa a ditsamaya go tse batho ba le gore ba lo phela wa phela ba le sha kumana ke la o sha o sha a sana ntwa ka o ja basina o re lo dino tsa go re le tshekana hore ditsamaya mara otherwise re ga nya go tsema gore na force ye existant ye e no sheta ke eng re found force we have got different types of forces. We've got two main different types of forces. We have the what? The van der Waals force as well as the what? The hydrogen bond. These are the two main types of intermolecular forces. Now, running van der Waals forces and hydrogen bond. Now, the two types of forces, they are fapana in terms of the strength. The two intermolecular forces, they vary in terms of their strength. Now, at the strength of the van der Waals forces, they are said to be what? Weak. Yet the hydrogen bonds are said to be what? Strong. Now, since the two intermolecular forces differ in terms of strength, let us quickly check come out the van der Waals forces. Because what van der Waals forces are weak forces. It are under van der Waals forces, the force. Namely, we have the what? The London force as well as the what? The dipole. Now, the London forces are also known as the what? The dispersion force. Now, in our London forces and dipole come kana batona diwangi weak. Mara level ya tsona ya weakness a ilekana. Ira dipole a tshwaneleng London force. Different in terms of a concept called polarity. So now, London forces are said to be what? Non-polar. Yet dipole are said to be what? Polar. Hydrogen bonds are said to be what? Very polar. Now we have the homologous series charina. So I try to measure the homologous series charina where the first stellar. Now we have alkanes, we have alkenes as well as alkynes. The two homologous cells they were under what? London force. We're going to have alkane, alkene, and alkyne. Now, under dipole, we have the what? The halo what? Alkanes. We have the what? What do we have? We have halo alkanes. Number two. We have the aldehydes. We also have the what? Ketones, as well as the esters. These are referred to as being the dipole. They are the force that exists between the dipole. Look at the dipole now. They are intermediate. Dipole are stronger than London forces, but they are weaker than what? Hydrogen bonds. Now we have two homologous things in falling under hydrogen bonds. Okay. Can you hear me? We have carboxylic acid as well as the what? Alcohol. Now, hydrogen bonds are like a carboxylic acid and alcohol. Mara, alcohol and carboxylic acid are said to be strong. Mara strength is such an acid. Now, more carboxylic acid and alcohol, which one is stronger than the other? Carboxylic acid are what? Are stronger than alcohol. Now, it's a question of saying why carboxylic acid are said to be stronger than alcohol. Now, if you take a look at the structure for carboxylic acid, let's quickly draw the structure here. Now, if you take a look at this one, oxygen in the periodic table, we arrange Dimitri Mendeleev, the 17th bond, Dimitri Mendeleev or oxygen in group number 6, so it's negative. Hydrogen is in group number 1, it's positive. Here, the bond is being formed. Can you see that? Yes. Down there, we have hydrogen, positive, oxygen, negative. A bond is being formed. Now, there are two sides where a bond is formed. But if you take a look at the alcohol, we just have C, then we have what? An O, then H. This side we have C, we have O, we have H. Now, let's take a look at this one. An oxygen, it will be negative, this one will be positive, a bond is formed. So now let's take a look at the two structures. Oh, carboxylic acid in an amabedi, our former hydrogen bond. More like alcohol in the site level one pair. Now we deduce by saying this bond should be broken. This bond should be broken. So we need to foresee to break this bond. So carboxylic acid is stronger than alcohol because carboxylic acid, they have what? They have more sites for hydrogen bond to form. It's now the homologous series still the class the what? What? K. These are the homologous series. Alkane, alkene, alkyne, alloalkane, aldehydes, carboxylic acid, alcohol, ketones, and esters. Look at the force that exists between. You know the force of cholesterol. Why it's one to lots of malapotulau. It's not about Tata, Google Potolere. The ways have to say, the village come from Google Potolare. Oh, the movie last month had more acid. But otherwise, the main concept here, we're going to check out the force. Now that we know the types of forces, and now that we know the homologous series, question 2 of the exam, question 3 of the exam, the fourth question. So now, it's going to come from Minato Manaka, Nakis now Tatagales, and some Kataroko, don't accept the box, Ravana Matama. Okay, sing it ball.
CNH